For the programming segments of the exam, along with loops, Boolean expressions and conditionals are pretty much the bread and butter of the programming questions that you'll get. Generally, you'll get a whole bunch of these questions, so it's going to be good to review them. The topics that are covered for conditionals are basically Boolean expressions, conditionals, and nested conditionals. Boolean expressions is just some simple stuff that we've known. They're true or false. We know about relational operators, which are equals, not equals, greater than, less than, greater than or equal to, less than or equal to. And then there's logical operators, which are not, and or. Be aware that regardless of the language that you're using, whether it be JavaScript or Python or whatever you're using for the class, the syntax for logical operators for this exam is not, and or, spelled out in words. For conditionals, the topics that they're covering are if, else, and else if. That's really all there is to it, but they can get pretty creative with these questions. And nested conditionals is just conditionals inside conditionals, but once again, these can get pretty creative. Usually the type of question you'll see with these is, which one of these statements is impossible to reach, or which of these statements can never happen? We'll go over a couple questions like that. This is a good question to start with here, because it kind of covers the definition of Boolean expression. So a Boolean expression is going to be one where the value of it is true or false. Of these, only one of these actually evaluates a true or false. Here, of course, we're assuming that temp has a value, let's say 50. This will evaluate to true. 50 is greater than 32. The answer here would be C, but it's worth noting why the other ones are not the answer. You notice that in all of these other ones, these are actually just doing assignments. These are all assigning a value to a variable. This one isn't even the correct exam syntax. But basically, when we're talking about Boolean expressions, what we're talking about is something that evaluates to either true or false, and that's it. Here we have a pretty common format for a problem that involves conditionals and Boolean expressions. What we have here is two variables. One of the variables is hot, and the variable hot has a value of true. The other variable is humid, and it has a value of false. So what we're going to do is we're going to see which of these statements displays true. There's two answers here. Now you can actually break this down and notice that whenever we have hot and humid, this will always be false. And the reason this will be false is because hot is true and humid is false. For the whole expression to be true, both of them have to be true because it's an and. On the other hand, this expression right here, hot or humid, evaluates to true. And the reason it evaluates to true is because hot is true and humid is false. And only one of them need to be true for the whole thing to be true. Since hot is true, the whole expression becomes true. So we can actually go down and see which ones of these will return true or will display true at the bottom. This will be true because hot is true. And this will be true because hot is true. Now let's look at the if statement itself. This one right here, we know that hot is true, so this will be true. But this first one will display false because hot and humid is false. So the answer cannot be A. Here's another expression we haven't seen, which is not humid. Since humid is false, not humid will basically flip that and turn it into true. So not humid is true because humid is false. So this statement is true. And since this is true and this is true, this right here will be true. So this is an answer. Now this one here is familiar. We already did hot or humid. We know this is true. And since this is true and this is true, then the whole thing is true. And finally, just to finish it up, hot and humid, we know hot and humid is false, so this one here can't be. So the answers are B and C. Keep in mind there's two answers. Here's a type of problem where we take a statement like these below, and we represent them as a flowchart. The best way to do these is actually just to reason through them. There's other ways that you can approach this, like plugging in numbers. You can plug in values for weekday and plug in values for miles and see which of these will get you to the right path. But that's actually kind of a long-winded path. The better way to do this is actually just to look through it and try to reason through it. So let's do that. What we see here is in this statement, we start here and we end here, but one of two things is going to happen. We're going to set available to true over here, or we're going to set available to false over here. This matches up with what's going on here. Notice that all of these are setting available to either true or false. On the left you have available, and on the right you have a Boolean expression. It's going to be either true or false. Now notice by going through this path here that in order for us to get to this point here where available is set to true, both weekday equals true has to be true and miles is less than 20 has to be true. That means both of these statements have to be true in order for available to be set to true. Also notice that if either of them are false, the whole statement becomes false. What this tells us is that the answer would be B, because we see here that in order for available to be set to true, both weekday equals true has to be true, and miles is less than 20 has to be true. If either of them are false, we end up going to this right branch where we set available to false. All of the other ones have different things that don't add up to that. Okay, now here's a problem where there's a whole lot of stuff going on. What this one's trying to ask us is we want these different statements to represent what is in this little box over here. So what this table tells us is that there's two types of tickets. There's a normal ticket and there's this other 3D ticket that's described down here, which is $5 more. But then there's also two price ranges. There's a normal, regular price range, and then there's a discount for children and for seniors. So if you have 12 or less years of age, you get the $9, and also the same if you are 60 or older. So we have a whole bunch of stuff going on. We have this, it's a 3D movie, but also there's a different age group. Now, if we were to graph this out, it would look kind of like this. We'd have a number line over here. I like to always do a number line when we have these ranges like this. And we might say if you're 12 here and if you're 60 here. So for regular, we have $12 here, and then this is 9, and then this is 9. And then for 3D, we have a different number line, right? It's very similar. So we have 12 and we have 60, but the actual prices are a little different. They're going to be 14 here, 17 here, 14 here. So in this range right here, we want to be 17 for the price if it's 3D and 12 for the price if it's regular. And over here, we want to be $9 if it's less than 12 or greater than 60 for regular, and then 14 for 3D. So that's basically kind of what the overall problem is asking. Now, once we start looking at the different options here, what we can observe is there's actually two types of if-else statements presented here. For A and C, we can see that we actually have an if and then another if. But for B and D, we actually have an if-else. This is actually different. The difference is that for the two ifs, if the first if is true, the second if can still also be true. Whereas for the if-else, if the first if is true, the else will always be disregarded. Same here. If this is true, we will skip over this else. Now let's take a look at these. The first thing that we can actually see right away is that part of the problem description describes that one of the ticket types is 3D, and we've all talked about it up here. But if we look at B and D, we actually notice that 3D is not mentioned at all. So these cannot actually be true because we never account for the case of a 3D ticket price. We only account for the age ranges. So let's check between A and C to see which one of these it might be. In A, we start with a price of 12, and if the person is less than or equal to 12 or greater than or equal to 60, we set the ticket price to 9. That seems reasonable over here, right? 12 in the middle or 9 in these ranges. So far it seems okay. But let's see what this statement is doing. If it's 3D, we're just going to set the ticket price to 17. Now that'll work over here for this price range. But if you are less than 12 or greater than 60, this is actually going to set the price to 17 instead of 14, right? It's basically always going to ignore this 14 case. The reason for that is because it's setting the ticket price to 17 regardless of what we did over here. So even if we set it to 9 here, as long as it's 3D, we kind of just disregarded this value over here. So we're missing that case. Now in this one, we do the same thing. We start with 12 and set it to 9 if they're less than or equal to 12 or greater than or equal to 60. But if it's 3D, rather than just setting it to 17, we actually set it to 5 more than the previous value. So if we were originally 12, it's going to set it to 17. But if it was originally 9, it's going to set it to 14. It's going to add 5 to it. So we still get the 17 case, and we also get the 14 case, which means that this one is actually the right answer. A is not. This is a pretty good problem because it actually covers a wide range of different skill sets, including setting variables, ranges of conditionals, if else, and various other things. This is another pretty common type of problem that we'll get with conditionals, and this involves some of these greater than or equal to, less than or equal to, some of these range expressions right here. The way that these usually play out is you'll want to get which expression captures a certain range of values. In this one here, we have like the number line like this, and we have a target point right here, call it T. And then there's this range, which is 10 more or 10 less than the target. So this is target minus 10, basically. And this right here is target plus 10. So let's say target is, as the example has here, 50. This point here will be 40, and this here will be 60. And what we want to see is which one of these will tell you whether the score is in this range over here, right? So the score can be 45, it can be 55, but it cannot be 65, nor can it be 35, right? So it can't be any point below here or above here. So in essence, the target has to be greater than 40, and it has to be less than 60. Now what makes this a little tricky is that the way that these expressions are written out, the order between score and target is kind of flipped all over the place. It doesn't have a consistent structure. So we'll have to look at these one by one. What we'll do is we'll read them in terms of the score, even when it's written like this. So for example, here this one says score is less than or equal to target plus 10, that is what we want. We do want it to be less than or equal to target plus 10. But look at the second statement. It says, and score is greater than or equal to target plus 10. It wants it to be less than or equal to target plus 10, but also greater than or equal to target plus 10. That's not what we want. We want it to be less than or equal to 60, but greater than or equal to 40, right? So this one's not correct, mostly because it doesn't mention anything about target minus 10, right? Let's look at this one. Score is greater than or equal to target plus 10. Notice I'm reading from right to left here. I'm reading in terms of score. We already know this one's false because this right here is not correct. We don't want to include anything where the score is greater than 60. So it's not B either. Now let's look at this one. Score is less than or equal to target minus 10, and score is less than or equal to target plus 10. So this isn't correct. We don't want this range. We don't want it to be less than or equal to 40. So this is not it either. So answer is D, but let's take a look at it. Score is greater than or equal to target minus 10, so it's greater than or equal to 40. That's what we want. And score is less than or equal to target plus 10. It's less than or equal to 60. So it's both greater than or equal to 40 and also less than or equal to 60. That's this range right here, and that's what we want. So the answer to this is D. For these types of problems, as you can see, having a little number line that you can visualize is extremely useful. You want to visualize, you want to really see what the range of values is that you're trying to get, and that can really help you reason through the numbers and variables that you have in the problem. Now before we get to nested conditionals, we'll do one more with just conditionals. Here's another very, very common type of problem that you'll see. These are simulating a computer circuit, which is actually pretty close to how things work in your computer's hardware. Simulates the idea of wires turning on and wires turning off, with a 0 being an off value and a 1 being an on value. In this case, instead of 1 and 0s, we're using true and false, and we see how these ands and ors take the place of something called a logic gate, which basically has a certain behavior depending on whether wires are on or off. So this is a logic circuit. And let's see how we do one of these problems. This is a type of problem where it's actually pretty cool that you are able to write all over your exam, because that's what you should be doing in this type of problem. So let's look at what we have here. We have a bunch of variables, A, B, C, and D, and we have these ands and ors. And what this is asking us is which one of these combinations will give us an output value of true. So basically what this comes down to is you're going to want to try all of these different values here and see which of them will end up evaluating to true. Let's use the A as an example so you can see what I'm talking about. So in A, we have A is true, B is true, C is true, and D is false. So that means that true or true evaluates to true. True and false evaluates to false. They both have to be true for this whole thing to be true. And then here we have an AND gate, and this AND gate here, for true and false, we have false, which means that the final output will be false. Right? So this is how we do this. We evaluate from top to bottom. That means that the value for A will be false. Now let's take a look at B. In B we have true, false, and then here we have false and true. So this one here will be true because true or false is true. And then this one here will be false because false and true is false. And then once again we have true and false. So this is false. So the output here will be false. So I think you kind of get the pattern here, that clearly this one here, they both need to be true in order for this thing to be true. So let's look at this one. In this one here, we have false or true. So false or true is true because one of them is true. And then on the right side here, we have true and true. So finally, this one will give us true here. So we have true and true, it's true. And finally, the output is true. The answer is C. Just real quick, we can see why D isn't the answer, despite the fact that this also has true and true here. And that is because on the left side, we have false or false, which is the only way we'll get a false on the left side here. So because this ends up with false on the left, and we need both of these to be true to pass through this logic gate with the true, this whole thing becomes false. So the answer cannot be D either. The answer is C. Now we finally get into nested conditionals. Nested conditionals, there's not really much to it other than the fact it's a conditional instead of a conditional. Usually what you'll have is you'll have an if-else, and then inside the else you'll have a bunch of other stuff. Notice in this one we actually have several layers of nested conditionals. What we need to know is that x has a value of 5 and y has a value of 10. The question here is which one of these is displayed when you run the program. So because x is 5, this first if is not run. We don't get into this because we will only get in here if x is less than 0. Since x is 5, we don't enter this. So we're not here. Instead, we're in this else. So if x is greater than y, we do this. We don't do that because x is not greater than y. X is less than y. So we don't do this either. So we enter this else. And here we say if y is greater than 0, we will say November. Otherwise, we will say Yankee. Y is greater than 0 because y is 10. So we go in here. We don't do this. The answer here is November, which is C. This is usually how you want to approach these problems. It's helpful to try to draw all over it to keep track of what the values are, especially if the values are changing throughout the flow of the program. Now here's a really interesting type of problem. These actually are also very common, which is kind of in the nature of which one of these will never happen? Which one of these branches can never really be entered? The idea is no matter what the value of n is, and it doesn't tell you what n is here, by the way. It just says it can be any value. But no matter what n is, there's one of these four that can never happen. Let's look at what these might be. Let's start by just plugging in some values. Let's say n is, let's say 0. If n is 0, what will happen here? N is not greater than 10 because it's 0, so we don't go in here. So we go into the else. N is also not greater than 100, so we don't go here, we instead go into the else. And we would display daikon. Now let's say that n is, let's say 200. N is 200, then we go in here, right? N is greater than 10, and also n is greater than 100, so we would display artichoke. Now what if n is 50? Just picking values that we know will get us into certain branches. If n is 50, we will go in here because n is greater than 10, but n is not greater than 100, so we would say broccoli. So here we've covered all of the different scenarios that can give us these three answers, which means the answer is clearly carrot. But let's look at this carefully and see why that is. What happens here is this top condition right here, n is greater than 10, is so over-inclusive, it includes so many values, that whenever a value would be greater than 100, we can never get here. We can never reach this because we will have entered through here first. This is one of these scenarios where you want to include your most specific case up at the top of a branch of if-elses, because if you have one that's too general like this one, n is greater than 100 or n is greater than 10, then it will always end up in here and it will never actually end up in here. So basically, always check to make sure whether you're getting stuck in one of the top level ifs, which will stop you from getting into an if that's nested inside your exception case here. We'll end this with this really interesting problem here, which actually covers a large number of topics, including conditionals, nested conditionals, variables, and simulations, being these random numbers right here. The key here is that we have these different outcomes, right? And we want to simulate these ranges of outcomes. Basically what happens here is 1/4 of the time the value is blue. Otherwise, it's either going to be orange or purple, half-half, right? So there's a half chance it's orange, half chance it's purple. But in order to come up with these, sometimes we're going to spin a random number from 1 to 4. So basically 1, 2, 3, or 4. If we roll a 1, we want to do blue. Otherwise, if this is our other outcome, we're actually going to split this in two. It's going to be either orange or purple. But what you notice here is that this isn't going to fit neatly into 2, 3, or 4. It actually means we're going to have to roll again. We're going to basically have to flip a coin, which is basically the same as rolling 1 or 2 and checking if it's 1 or 2. But right away here, we see that our outcomes mean that we can very easily check for the blue case by just making sure that whenever we roll 1, the answer is blue. So that fits here. By the way, there's two answers here. So that works here. If random 1 through 4 equals 1, we display blue. This one works too. If the spin is 1, we display blue. That works too. Here's another one of those. We have a spin from 1 to 4, and if the spin is 1, we display blue. So all of these show that there's a 1 in 4th chance of getting blue. This one does not. This one says if random from 1 through 4 is greater than 1, we display blue. This one will display blue 3/4 of the time, right? It will display blue for 2, 3, and 4. So this one's not correct. This is not the right answer because of this top part right here. Now let's look at the other part, which is the really interesting one. 2 of these will be correct for the bottom part. 1 of these will be wrong. So what we want happen here is basically if we roll 1, we get blue, but otherwise we're going to want to flip a coin to see if it's orange or purple. We're going to want to do half of the time orange, half the time purple. Let's see what this one does. So here, if it's not blue, we're going to do random 1 through 2, and if it's 1, it's orange, and if it's 2, it's purple. Or rather, if it's anything else, it's purple. So it's either going to be 1 or 2, and depending on which value it is, it's orange or purple. So that is correctly 50-50, right? It's either 1 or 2, flip of a coin. Let's look at this one. Here, if we don't go into blue, we're going to check whether or not spin is 2. And if it is, it's going to say orange. Otherwise, it's going to say purple. Now, this isn't going to work because if you remember, the spin, which we determine here at the beginning, is either 1, 2, 3, or 4. It's one of these 3 values. And what this means is that if it's 1, it's blue. If it's 2, it's orange. Otherwise, it's purple. What that would mean is that we have this situation right here. 1 is blue, 2 is orange, and then otherwise it's purple. Now what you might notice here is that blue and orange are equally likely here, but purple is twice as likely as both blue and orange. So this would actually be closer to a pie that looks like this. It would be blue, orange, and purple. 1/4 of the time blue, 1/4 of the time orange, and half the time purple. So this isn't going to work either because of this down here at the bottom. Now let's look at this last one here, which is as before, 1/4 of the time we start with blue. Otherwise, just like we did in the part A here, we're going to spin a random number from 1 through 2. And if it's 2, we display orange. Otherwise, it's going to be 1, we display purple. And that's the same thing as we're doing here. The only difference between A and D is that in D, we're storing things into this variable called spin. And in A, we're just doing the random number on the spot. We're just evaluating it here, right? So there's really no difference between D and A. They're just using a variable or not using a variable. But the actual logic is exactly the same. So flip of a coin here and roll 1 through 4 here. So the second answer here is D. This is considered a pretty tricky problem. This is probably on the harder side of the problems we'll get. But if you reason through it, if you think about it little by little, you can figure it out.
Thanks for watching. I'm Flavio, and I'll be back with more soon.